Hello dear students, how are you? Today lesson in math is the area of a parallelogram and a trapezium, page 167. The objectives: how to determine the area of a parallelogram and how to determine the area of a trapezium, and then we shall make an exercise to see this in real life. Okay, how to determine the area of a parallelogram. The area of a parallelogram is the same the area of a rectangle. If you tell me how is that, this is a parallelogram, okay? We know that if we cut now this area here, just a triangle from the parallelogram, if I cut this area from here and I take it to this place, okay, then I have a rectangle. So this is a rectangle. So what did happen? Nothing happened. The area, if I suppose the area here is, for example, 50 centimeters square, okay? If this cross-sectional area here is 50 centimeters square, and I cut this triangle and I put it here, did I change something in the area? No, only I took a piece from the area, I put it here. So I didn't minimize or maximize the area. It's still the same. So if I change it like this, I have then a rectangle. That's why it is the same. It is the same formula. This is the height and this is the base, and you can also, this is the base and this is the height, and you can use the same formula, base and height. This is the base and the height. Base times height, you find the area of a parallelogram. Because as I said you, this is no change in the area of the there's no difference between a rectangle or a parallelogram, okay? And why? Because the cross-section area of the parallelogram, when I change it to a rectangle, never changes, stays the same. That's why I can use the same formula. So what about a trapezium? How can I find the area of a trapezium? This is a trapezium, okay? It have also height and base, but there's another base at the top. Always the big base is B and always the small base is A. So I have two bases here and I have a height. So how shall I find the area of a trapezium? I know that the area, it is base times height. This is what we do by the rectangle and by the parallelogram. So how can I do this for this one? Suppose we have two trapeziums, okay? Now I have not one trapezium, I have two trapezium. What shall I do? I shall take one of them and flip it, okay? Okay, this trapezium have base. This is the long base B and the short base A, and this is the height. So I shall try to flip this one. It's going to be like this. If I join it to this one, what I have now, this one, what does it look like? What does it look like? It looks like a parallelogram again. So yes, I can use the same formula also for the trapezium, but we have a problem here. Two problems, in fact. I need the cross-sectional area of this one, not both of them. So I have two of them, so I have to make it in half. This is one thing. Second thing, the base here is now too long. It is B and A. So because if I like to use this formula here, I have to multiply the base by the height. The height is the same height, but the base now here is all of that. So it is A plus B. So if I use the formula, I have to write, instead of base, I write A plus B. Okay, so the base here is A plus B. It's all okay now, but the problem is still I have two trapezium. I need the area only of one trapezium. No problem, you multiply it by half. So this half is because I need only one trapezium, and AB because the base now is two bases. It is the small a and this and the big B. So I add them together and multiply by half. So if you need to find the area now of a trapezium, one trapezium, you use this formula here: a half multiplied by the big base plus the small base multiplied by the height. You add both of them. You add this base, you add it with this base, you find the sum of them, and then you multiply it by the height, okay? And then you divide it by 2 because I need only for 1. I only make this to show you from where did this formula comes from where it's driven. It's driven from the same formula from the parallelogram or from the rectangle, but this is the explanation from where this formula comes, okay? Now we go to exercise 17.2. Work out the area of this parallelogram. Okay, we have this is the same area of parallelogram, base multiplied by height. So the area of parallelogram is 6 multiplied by 3, how much? 18 centimeter square. Please don't forget the unit. The unit is very important. If you write me centimeter, 1 point is away, because centimeter is for length, centimeter square is for area. Okay? Thank you very much for your attention.